Morning, Algebra 2. Hope you guys are doing all right. Last lesson of the week. This is synthetic division. Let's make it happen. It's going to be a beautiful day outside. I am eager to get outside a little bit. I got a lot of sticks to pick up in my yard today. So let's get this stuff done. We are moving right along. Okay, we are talking synthetic division. So yesterday, our last lesson was dividing polynomials. This is another way to divide polynomials called synthetic division. It's an efficient way to divide a polynomial by a binomial that's in the form x minus c. So the coefficient of x is 1, the leading coefficient is 1, and c is a constant. Right, here's an example. We are used to seeing them in this form right here. A polynomial divided by a binomial. This is the exact same thing, a polynomial divided by a binomial. And this is in the form x minus c, where my leading coefficient, or my coefficient of the variable, is 1. Okay, here's how it's done. I'm going to start by getting the root of the divisor, getting the root of the divisor. So in this case, the root is -3. I'm going to list out all of my coefficients. Make sure your coefficients of your polynomial, that they're all there, that you've got x cubed. They're in descending order, x cubed, squared, x to the first, x to the 0. If you're missing any, you'll need a placeholder there if you're missing one. I've got all of them here. So 2, -5, -1, and 3. Those are the coefficients of the polynomial. I'm going to do what this pink step right here says to do and just write the 2 down below. Okay, and then it's just this game of multiply and add, multiply and add, multiply and add. I'm going to multiply my divisor, -3, the root, -3 by 2, and get -6, and add the column to have -11. -3 times -11 gives me 33, and then add the column. -3 times 32 gives me -96, and then add up the column. My remainder here is 93. -93. And so my answer, if the remainder is 0, that means that my polynomial is divisible by my divisor. But if I have a remainder, then I would have -93 over my divisor, x plus 3. Another thing worth noting is that this is a cubic divided by a linear, so I would expect it to be quadratic. It's power 3 divided by power to the 1, I would expect it to be to the power of 2. Okay, let's just jump right in and try one. I'm going to try number 5, 17, 19, and 23. I think there's one more, 13. I was going to try number 13. Okay, here we go. Number 5. First up, I need to know my root. My root in this case is the root of the divisor, -5. It's a root or a 0. I'm going to write out all of my coefficients of my polynomial and make sure my polynomial is written in descending order and that I have a placeholder 0 for t squared. 1, 5, 0, -2, -7. I'm going to write the negative or the positive 1 down there, and then it's this multiply and add, multiply and add. So -5 times 1 is -5, add the column, 0. -5 times 0 is 0, add the column, 0. -5 times 0 again is 0, add the column, -2. -5 times -2 is 10, add the column, 3. Okay, I'm going to expect my solution to be t to the third. So this is 1 t to the third, write this if you need to, 0 t squared plus 0 t minus 2 plus 3 over t plus 5. I'm going to write it one more time without the zeros in there. T to the third minus 2 plus 3 over the quantity t plus 5. You certainly don't need to do that other step if you don't need to do that other step. Okay. Looking good. You should be good to go on most of these on the front page. Some of them, you get into this trap of a lot of zeros. I'm pretty sure number 9, let me look. Yep, number 9's got some funky things going on. But you can do it. Number 13. Okay, I've got a polynomial divided by a binomial, and this is good to go when my coefficient of that root is 1, dun dun dun, and it's not. So now what? Well, let's force it to be 1. If I were to divide this by 2, or if I were to, in other words, multiply it by a half, then my coefficient would be 1. So let's see here. 1/2. Okay, if I pull out the 2, or if I factor out a 2, or 1/2, if I factor out a 1/2, then I've got that as the denominator. So now I'm good to go. I can do this, do synthetic division for this, and then divide by 2 at the end. That's my game plan. So let's do synthetic division for that. The root in that case is -1/2. Nothing wrong with that. That's my root, -1/2. Write out my coefficients. Okay, multiply and add, multiply and add, multiply and add. Gosh, just gotta be very careful. I have a tendency to just make careless mistakes. One little mistake at the beginning is just a chain reaction. Check my answer. Yep, yeah, wait. Yep, I'm good to go so far. Okay, I'm gonna write out my answer. This is 2x squared minus 4x plus 6. I'm going to say plus -5 over x plus 1/2. Okay, well, that, however, is the answer to this. So now I need to divide that by 2, or multiply it by 1/2. So then my actual answer is going to be, it's like I'm distributing the 1/2 or dividing every term by 2. 2x plus 1. Okay. Looking good. All right, and that is what I set out to do. I set out to divide that polynomial by that divisor, and my final answer has that divisor in there. Okay, looking good. You can try number 15 is a lot like that. Let's try number 17. Number 17, let's see, I've got a polynomial divided by a binomial, and it has an I in it. Woo, complex numbers, yeah. Okay, first up, what's my root? My root in this case is 2i. I'm going to write out my coefficients. I'm going to do the same thing I did before. Oh, you know what? I'm going to give myself just a little more space because I know what's coming. Okay, I'm going to write out the 1 and go to work. I've got everything set up, and it's again multiply and add, multiply and add. So I'm going to multiply. 2i times 1 is 2i, and I'm going to add this column, and I get 2i minus 2. I get all of that. And then I'm going to multiply and add. When I multiply, I get 4i squared, which is -4, minus 4i. I get that whole big thing, the complex and the real part. I'm going to add them and get -4i. And then I'm going to multiply 2i times -4i. That's -8i squared, which is the same thing as +8. Add them and get 3. Okay, I'm going to write my answer. It'll be z squared. So I've got z squared plus, let's say, write it that way, z squared minus 4iz, well, let's see the first, minus 4i plus the remainder 3 over 2i. Let me double check I got that right. Wait. Nope. Right down here. Z minus 2i. There we go. That's a good answer. Another good answer, you could expand this out. If you wanted to expand this out right there. Both are great answers. Okay. All right, so that was the exact same thing. I just had some i's in there. Trying 19 and 23. Okay, 19. Find the polynomial q of x and the constant r. Find the polynomial q of x and the constant r. So I'm going to divide both sides. It's like I'm going to divide both sides by this. So my root of that guy, -3. My coefficients, don't forget that placeholder. And then go to work, multiply and add, multiply and add. Okay, what the heck did I just do? Well, that would be the divisor times the quotient plus the remainder. So the quotient is 2x squared minus x plus 3. So that's the quotient. And the remainder is 5. The remainder is 5. So the remainder is just 5. It's not 5 over x plus 3. And if I were to distribute this out, I would get this polynomial. So if I were to do the divisor times the quotient and add the remainder, I would get the polynomial. That's all that's saying. Try number 21. It's the same kind of thing, but you do have a 2i in there, so you're going to have some complex things going on, but you can do it. Okay, one last one for me to try. It's got a k in it. I know how you love those k problems. Let's see. Find k so that this is a factor of this polynomial. So the divisor is a factor. That means my remainder, if it's a factor, then my remainder is 0. There's my root. Write out all of my coefficients. 2x cubed plus 3x squared plus, don't forget placeholder, 0x plus k. Because I have 0x in there, plus k. Okay, multiply and add, multiply and add. All right, here's my column. When I go to add, I want to have a remainder of 0. So what is the value of k? That'll give me a remainder 0. K would have to be 4. All right, see what you can do in number 24. Number 24, the k is right here, but you can still figure it out. Remember, the clutch part of this, or the key part of this, is that the remainder is 0. You know there's going to be a 0 there if it's a factor. All right, good luck. Email me if you have questions, and